Okay, so I'm not going to rewrite this. A lot of things happen. I'm tired, but I want to get this out for you guys. So we're going to factor this quadratic inequality. The first thing we need to do is write it into our two binomials. Remember, we need to figure out what two numbers multiply to -4 and add up to -3. In this case, we're going to have -4 and 1. Once we have separated into two binomials, the zero product property allows us to separate it. And now we could solve for our x minus 4 greater than 0 and our x plus 1 greater than 0. And we get that x is greater than 4 once we add the 4 to both sides and subtract the 1 of both sides. These become our critical points. This is why we make them equal to each other. Our critical points are basically zeros. And if we look back to the graph that I did earlier on the top, they're basically our x-intercepts, where our graph crosses the x-axis. The next step is to figure out our test intervals. So our test intervals are basically from the left to the right. So I know I have -infinity to that 1 would be our first test interval. That means I need to find a number from there and check if those numbers gives me a true or a false statement. My next test interval will be from that -1 to that 4, this little section. And our last test interval will be from that 4 to positive infinity. So I'm testing every section and I'm getting a number in here from every test interval. I do not want to pick a big number just because when plugging it in, it'll be a big number. My suggestion is to get a number that's close to your actual x-intercept. So I'm just going to pick -3. And when I pick -3 and plug that into my original equation, technically you can plug it into either of these because they're basically the same equation. I got that 14 was greater than 0, which is a true statement. So that means anything that I picked on this side was going to be a true statement. This means this is part of my solution. Then I picked 2 from the inside interval. And when I substituted the value, I got that -6 was greater than 0. That's a false statement. That means everything right here in the little green part is false. That nothing could be my solution. Then I picked x equals 5 from this interval right here. I substituted in, simplified it, and I got x is greater than 0. Since that is a true statement, I know that this test interval works, which means anything from 4 to infinity is part of the solution. So if I want to write this as a graphical representation, basically what it means that from -infinity to 1, all of these numbers are part of my solution set, not including 1, -1. Everything in between is not part of my solution. Then at 4 is my starting point, but not part of my answer. Anything greater than 4 is part of my solution. If I want to write it as a solution set, it would be -infinity to -1 with a parentheses, the union, and then parentheses 4 to infinity. The union basically represents this part right here, that there's no solutions for this specific problem. For this problem, it's basically the same thing. The only difference is I have to write it in standard form. So I subtract the 12 to the other side, and then I factor it. I get my solutions, where these will be my critical points. Once I find my critical points, I set up my test intervals. And my test interval will be from -infinity to -4, from -4 to 3/2, from 3/2 to infinity. So I'm literally testing every single piece of a number line. I'm testing the left, the middle, and the right. I get -5 for my first interval, and I test it out, and that becomes a true statement because 13 is greater than or equal to 0. I get a number from the middle interval, which I picked 0, and I get -12 is greater than 0, greater than or equal to 0. That's a false statement, so that cannot be part of my answer or my solution. Lastly, I pick x equals 2, substitute it in there, and I get 6 is greater than 0. That's a true statement, so that means these two are the ones that or all my answers, all my solutions reside in. So if I do a graphical representation of it, again, negative infinity to negative 4, including negative 4, is part of my answer. This is why I have a bracket. Everything between negative 4 and 3/2 is not a solution. So that's why it's empty. Then at 3/2, it's part of my answer. So that's why I have a bracket, and it goes all the way to positive infinity. If I want to write it as a solution set in interval notation, I would go from negative infinity, parentheses, to negative 4, bracket, union, bracket, 3/2 to infinity, parentheses. For this problem, we started in class, but we didn't finish it. I'm going to finish it here. The only thing that we needed to do was the solution set. But if you notice, because this is a cubic and all of them have an x in common, I took out the greatest common factor out, which was x. Then I had a trinomial, and then I factored that trinomial. And I got that I had 3 critical points. X is equal to 0, x is equal to negative 6, and x is equal to negative 1. Since those were my critical points, I have to test all the pieces, all the sections. I have to test from negative infinity to negative 6, from negative 6 to negative 1, from negative 1 to 0, and from 0 to infinity. So all of these little sections, I need to test if there's a solution in there. I identify specific numbers for each of those test intervals. I worked them all out. And I figured out that it was true from a negative infinity to negative 6. It was false from negative 6 to negative 1. But everything from negative 1 to 0 was true. And everything from 0 to infinity was false. If I write this as my solution set, my answer would be negative infinity to negative 6, union negative 1 to 0.